What I'm going to talk about today is the oil spill that happened this past spring and kind of what the response was from both the company as well as the regulatory agencies and what some of the effects were that we've seen on the Red Deer River. So there's a very quick introduction here. As everyone knows, the Red Deer River watershed forms part of the South Saskatchewan Basin. It drains east from the Rocky Mountains to Saskatchewan and then meets up with the South Saskatchewan River just past the Alberta-Saskatchewan border. It's relatively sparsely populated upstream of the Dixon Dam. The majority of agriculture industry and population is downstream of the dam. When you look, there's where the Red Deer River watershed is in red. It does actually encompass a little bit of Calgary as part of the watershed, so it's a fairly good size watershed right in the middle there. You can see just in terms of the subregions, you're going from sort of foothill areas down to parkland and grasslands as you move east. So it's quite a bit of change in the natural regions as you move downstream in the watershed. As I was saying, where the space is, that's where Glenifer Lake is and where Dixon Dam is. So pretty sparsely populated upstream of Dixon Dam. Sundre is about the biggest center. Most of the population is downstream, Red Deer being the biggest municipality. So in terms of the spill itself, the spill, it happened on June 7th of this year. It was a pipeline that was owned by Plains Midstream Canada. It ruptured and spilled, they estimated upwards of 500,000 litres of light crude oil to the Red Deer River, right downstream of Sundre. It actually is upstream of where Sundre discharges their wastewater from the town of Sundre. So it was really close to Sundre, and it was noticed by residents at Sundre. They smelled the smell of the oil as it was going into the river and notified the local SPOG, it's called, and it's Sundre Petroleum Oil and Gas Producers, and they notified Plains. So the initial response over June 7th and 8th was a plugging, of course, of the broken pipeline. So they cut the pipeline further up on the shoreline and put in a stop block there to stop any further flow going into the Red Deer River. And then there was some boom placement in Glenifer Lake. I'll show in a figure here shortly, but it was during really high flows, like during really high spring flood flows, that this occurred, and putting booms upstream of the reservoir just wasn't possible. They actually did try and get some booms up in those areas, but they just got washed out. So the first location they really could put it was downstream in Glenifer Lake. Town of Sundre is right here. This is where the point of entry was, where the release was, and then flowing downstream, so you can see how close it was to this town of Sundre. And again, just sort of a bigger map. Here's Sundre, and there's Glenifer Lake. So it flowed as far downstream as Glenifer Lake, but there, I'll show this in a few minutes here. But there was detectable concentrations as far downstream as the city of Red Deer. You can see some of the challenges that we had for working with this oil spill. It's highly braided system. It's a wild river upstream of the dam. For a lot of people that are familiar with what the river looks like, where it's relatively channelized downstream of Dixon Dam. Upstream, it's a very wild river. There's all sorts of little side channels all over the place, and so kind of the oil went all over the place. It spread out all over on here. Here's at the beginning of June, so you can see when the peak was, and that's when the pipeline break occurred. So it was right at the peak flood, and then the decreases. And this is pretty consistent. If you lay over subsequent or other years, you'll see pretty much always get this peak in June, and then it decreases over time, corresponding sort of to the snow melt up in the mountains and coming into the Red Deer River. Here's a boom placement across Glenifer Lake. We've got another picture here, and that sort of shows you what the size of these boats were. These are about 15-foot long boats, and putting out these booms, so quite large booms. They ended up putting about, I think a maximum they had about 5 booms placed across the lake downstream near well, at the entrance, about midway point, and then downstream, and then they had some other ones in there as well. On June 8th, the Plains initiated their water quality and wildlife monitoring, as well as Alberta Environment Sustainable Resource Development and some of the other agencies. We also initiated monitoring at that time. The cleanup operations started soon after. Initially, it was recovery of that visible free product that floats on the surface, that black oil that everyone is familiar with. The drinking water facilities for the Carefree and Glenifer resorts, which are the two resorts on Glenifer Lake, they were closed at that time because of the fact that there were these detectable levels of hydrocarbons and higher levels of hydrocarbons in the reservoir. The Anthony Henday and the Red Deer plants, they were closely monitored. They were typically monitored about 2 times per day at the start. And then, of course, there was a great deal of media interest. So here I am. This is out on the reservoir and collecting some water quality samples. This is some of our staff out on the Red Deer River. This is downstream of the dam and collecting water samples. Sort of a typical, what we end up getting all these water samples from this is from 2 different sites, but quite a few water samples collecting for things such as petroleum or PAHs, dissolved hydrocarbons, oil and grease, those sorts of things. This just shows you, I guess, where the reservoir, and this is where one of the other booms was placed. This is the Carefree Resort, and that's the Glenifer Lake Resort over on the other side. So these are the 2 resorts that are on Glenifer Lake. This is a picture that the Red Deer Advocate ran. So this is one of the critters. This is Oily the beaver, and he did get soiled by the oil. So of course that ends up generating a great deal of media interest, and we got a lot of people coming out to talk to us to find out what the progress was and how the cleanup was going. So in terms of the spill itself, the migration of the visible oil product, it was stopped effectively by the booms. So that's that visible oil, so that's the oil that's sitting up on the surface. So the booms are pretty effective. They sit on the surface and they have a little curtain that goes down into the water, about 1 meter down into the water. And so they were pretty effective at stopping any of the oil from going further downstream than Glenifer Lake. However, the dissolved product, it moved into Glenifer Lake, and it moved right downstream of the reservoir. So this is, dissolved fractions of it that are mixed throughout the water column. So we didn't expect in that case that they would be stopped by the booms. And so they did just move right past the booms, right past the dam and further on downstream. So essentially we ended up having 2 different systems and sets of effects. So upstream, we have that visible oil product. So we had the soiling and smothering of aquatic organisms and wildlife. As kind of the main issues, and plant as well. Downstream, there was potential toxic effects from the dissolved constituents. For the water quality monitoring, it was primarily carried out by the Plains, by their contractors, with us sort of supervising and basically telling them what we wanted to have collected. Our role was more one of assurance and validation, and it's just a matter of the amount of resources and stuff that we had available. But I mean, in cases like this, we do expect that the proponent or the company is going to do the majority of the sampling, and so ours was more of a check to make sure that their data matched up with our data, and it did, which I'll show here shortly. We had this well-defined pulse of the petroleum hydrocarbons and the polycyclic aromatic hydrocarbons that were observed downstream of the reservoir, from the reservoir to downstream. And some of those hydrocarbons, they were above the protection of aquatic life guidelines, notably toluene in this case. So we look at sort of the evolution of this, and these next few graphs, it'll just go day by day. So starting on June 8th here, we can see this is from the break point, so they're sampling upstream of the break point. So from the break point down to Glenifer Lake, there's these stations, and then from Glenifer Lake, and there's one of the booms, and another boom, and then the dam. And then this would be downstream of the dam on this side of things. And we can see sort of where our sites were, as well as where Plains, where their sampling sites were, and you'll see that it kind of expands over time. But anyways, on that very first day, we saw that the majority of the hydrocarbons had reached the lake by that point, and there was kind of a large concentration of the dissolved fractions in the lake itself. By the following day, it had gone from, so the break point, we still got a few detections, but from the lake and further downstream is where we saw the majority of it, and we were seeing that the concentrations on here, the toluene being in blue and that being the relevant line. You can see that quite a few of the toluene concentrations were exceeding the aquatic protection, aquatic life guideline. And so we sort of see a similar thing. It just sort of continues going downstream. And then from June 11th to June 12th, we actually saw a fairly significant drop, and it kind of continues that way. We keep seeing it, the concentrations dropping over time to the point where by June 16th, we no longer had detectable concentrations of those dissolved fractions of the hydrocarbons. So, as I said, a fairly well-defined pulse of hydrocarbons that flowed through the system and further downstream. The drinking water plant monitoring, as we were saying, there was monitoring done on drinking water plants, done about twice per day for these same parameters. We're looking at the concentrations of the petroleum hydrocarbons and the PAHs. We found that in all cases, and this was at the Anthony Henday and the Red Deer drinking water plants, that they were below drinking water guidelines. The drinking water plants, however, they were shown to be relatively ineffective in removing any of those petroleum hydrocarbon products that were detected. So this is set up a little bit differently in that it goes from the earliest date to the latest date. And you can see here we've got the raw intake water, and then we've got sort of the post-treatment water and the white dots, so the black dots and the white dots. And you see the concentrations are pretty much the same as you move along. And this is for, I think this is the Anthony Henday plant, and this one is the Red Deer plant. So in both cases, for the Anthony Henday and the Red Deer plant, really didn't take out, this is for benzene in this case, really didn't take out any of that dissolved benzene, that dissolved hydrocarbon fraction. And we see that for the other parameters as well. It really isn't taking out much of it. So, you know, it does have some implications. This is something for us to think about as we're moving forward to is, okay, well, the concentrations are well below the drinking water guidelines. Luckily, those treatment plants were far enough downstream that you know, the concentrations weren't high and that we didn't run into problems with those drinking water guidelines. But if there was a pipeline break that was closer to it, would we have gotten to that point where we actually had to shut down the plants? And I can tell you that Alberta Health was prepared. They actually had an order in hand that said, you know, if they did go by the drinking water guidelines, that they were going to shut it down and force Plains to truck in water to all the residents. So we're talking about 150,000 people that are served between the Anthony Henday and the Red Deer. So you can imagine the logistical nightmare of trucking in water, drinking water for that many people. So it's something for sure that we're looking at to sort of see, well, in terms of emergency preparedness, is there something more that we should be doing for potential situations like this that might occur in the future? And that's the xylenes here. The cleanup process. So as I was saying, the majority of it was focused on removing that visible oil product and preventing any further sort of degradation, dissolved hydrocarbons from reaching into the water. There's significant challenges. First of all, due to the high flows, contamination is largely ended up being above water in the backwater areas. So it was at the highest point of the flow when that break happened, and then the water levels dropped, as you saw from that hydrograph. They dropped quite a bit right after that, and so all of this oil was stuck high and dry in the willows and in the trees and so forth. So there's a number of techniques used, but for minimizing the impact on the environment and for just simply access issues, there was a heavy reliance upon manual cleanup and removal of product. And manual cleanup is literally going out there by hand, and they had like hundreds of people going out there and cleaning and scrubbing off rocks and so forth. So you can see here what I mean. Here's where the water level, this is actually still when it was relatively high, but you can see this is all where the oil product was in the willows. Again, where the water level was, but you can see where the oil. So it left kind of, we called it a bathtub ring of oil in these sort of higher areas. This is actually near the break point. This is actually at the Pembina pipeline, which was just downstream of where the Plains pipeline was. But you can see how high up the oil came at that time, and by the time I was out there, it was well below. The water level was well below it. And then there's some of the challenges in the area. This area here, you can't really see it, but it's really, really steep-sided. They actually had to cut in stairs to get down to that area, and you actually had to take sort of like this rope ladder system to get down into the area. And then you've got all of these bags that were filled with with contaminated product, and the only way to end up getting out of there, because getting airboats and boats upstream was really difficult. So what they ended up having to do is they'd have to take a helicopter and sling it from there up to the top, and then load it up onto trucks to remove. So a lot of challenges for doing this work. And this is a view of the same area, looking at it from up on top of the hill and downstream. So you can see in some cases the degree of cleanup varied. In some cases, I mean, this was a heavily pooled area of oil, and so it was literally, this is a guy with a kind of an industrial weed whacker, and he was out there cutting all of the vegetation. This is mostly peat moss in that area. In other areas, it was more of a gentle cleanup in terms of cutting the willows down, but not right down to the base, to allow them to recover, and minimizing the amount of use of peat moss in those areas. This one I just put up here quickly because it was kind of interesting. This is like the break was downstream, but the reason this area is cleared is because that's where the Pembina pipeline ran. So that area was cleared back when there was the Pembina break and when they needed to access the area. So you can see how close it was to that pipeline. And those are the stairs that I was talking about, with the rope system that you had to use to get down to the bottom. And here's just more, cleanup on the shoreline. This is of some of the contaminated soils and stuff up in the area. Here's another kind of cleanup thing. This is actually at the cofferdam, so at the break point, and this is a system where they put in these sort of isolation chambers into the water, so then they could get in there and they could stir up the sediment, get any of the oil that was trapped down in the sediments to float up to the surface, and then clean it up that way. And this sort of isolation system, minimized the amount of turbidity and the amount of suspended sediments that were going to flow downstream in the system. And just some more pictures. The flagging in this case was used for deterring wildlife, so deterring birds and so forth from coming into the area. And you can see they had all sorts of little mini boom systems set up to keep the oil that was in these backwater areas from going into the main part of the river. And this was actually at the Carefree Resort, where they also had an operation set up, and you can see a lot of the debris that came down from the river, and it had been soiled by the oil as well, and so that was captured in the reservoir and then brought over to Carefree Resort and gathered up and trucked off and chipped and taken to a facility for disposal. And this is a system that they used on the reservoir itself. In this system, it goes into the water and pulls the hydrocarbons, the free hydrocarbons, up into the boat. So as I was saying before, challenges. The river was highly braided. Water levels, they dropped, making access an issue in a lot of areas, and it did end up having to be a bit of a challenge in terms of, well, where would the oil be, because in a lot of cases, of course, the water level was down, so it wasn't by the water, and you had to walk a fair ways back in some cases to find out where the oil was. In some cases, oil, it was trapped in settled sediments underneath trees and other debris, so it created more challenges for finding where the oil was and then removing it. So you can see in this case here, I mean, this is what you get after a spring flood. You get tons of this debris all over on the river, and so you'd find these little pools of oil. This is oil right here that are kind of almost hidden underneath some of this debris that you'd have to move out of the way and then extract that and get rid of the woody debris as well. This is where there's oil trapped in the sediment because it was really high suspended sediments during the spring flood time, and then it settled down onto the sediment, but they knew that there was a layer of oil trapped under it. So this is a stinger operation where they pump some water into it, and then that would sort of stir up the sediment, and then the oil, the free oil, would float up to the top, and then they'd be able to remove that oil. And that's just more of that operation. In terms of the pipeline removal, so of course they had this pipeline that had ruptured and needed to remove it from the system. So what they did first was they installed a cofferdam and sheet piling. Cofferdam is kind of a dam that isolates just a little section of the river from one side of the river. So they did that around where the pipeline break was. Then they flushed the pipeline, they cut, and they removed the broken section of the pipeline at that point. The removal of the pipeline and the decommissioning of the cofferdam is completed by September 13. So it took a while for it to work to do. Again, there was a lot of challenges that they had in terms of removing that pipeline because they had to get all the water out of that cofferdam area, which is why they needed the sheet piling, and then they had to excavate it and then cut it and remove it out of there. So this is where the cofferdam, so the dam, it extends out into the river like that, and this is an example of the sheet piling that they were using with the backhoes. They'd have this vibrating thing to put it into the middle of the cofferdam and then pump out all that water. And so there was a whole bunch of additional monitoring that we had asked them to do at that time in terms of the suspended sediments and stuff while they were doing that work on there, because of the fact that the suspended sediments can affect the fish habitat, the fish spawning habitat too. Long-term monitoring. So there was, of course, because we saw those exceedances in the aquatic life guideline for some parameters, there was potential long-term impacts to the receiving environment from both those dissolved parameters as well as that visible oil product. So there was a fishery survey that was conducted for consumption advisory. The fisheries was closed down upon recommendation from Alberta Environment and Sustainable Resource Development. They're currently conducting their long-term water and sediment quality and their non-fish biota monitoring, as well as what they call this SPMD, which is a semi-permeable membrane device. So it's these little membranes that they leave in the water for a month, and it kind of simulates what it'd be like for like a fish gill or something like that, and all the water going through it and accumulates any of the hydrocarbons over time. And then there's further fisheries work that's beginning in October and November. So this work should tell us, like, okay, well, we've had this oil spill and it's gone into the system, and we know that we had some exceedances of some of the guidelines. Is it going to have any long-term impact on the aquatic environment from either that visible product or from that dissolved fraction of the oil that went into the river? So this is just some photos again of some of their field staff conducting some of the sampling, doing some flow monitoring here. This is for collecting benthic invertebrates, so that's the little critters that live on the rocks or under the rocks in the river. This is just flushing that out. This is collecting the algae off of the rocks, so we want to see if the algae that are growing in the river, if they had been impacted by the oil spill. This is a picture of the SPMD. This is actually just a container, and the SPMD is inside of the container. So that's that. So if anybody was up in the upper portions of the Red Deer River and saw these little floats in the river at that time, that's what that was. They've all been pulled out now, but they had them in there for about a month to sort of see if there was any accumulation of hydrocarbons at that time. So, of course, it comes back to what was the cause of that failure, or in other words, what's the $54 million question? $54 million, because that's how much Plains has estimated it's cost them for cleanup to date. The pipeline, it was internally inspected in the last year and is found to be in acceptable shape. The pipeline, the last time they examined it, it was buried 0.81 meters below the riverbed, which was, for pipelines at that time, was 0.8 meters is the minimum distance they're supposed to be below the riverbed. The re-examination, though, of pipeline crossings showed that there had been significant erosion in the last year. So my thoughts, and this is my thoughts here, is that similar to the Pembina pipeline failure, it is likely that the pipeline had ended up becoming uncovered because of the high river flows at that time, and there was some sort of rupture externally. In the case of the Pembina pipeline, it was a mature fir tree that slammed into the pipeline and caused it to break. They didn't see anything like that this time, but it could have been something else, like a rock or something. I mean, these are good-sized boulders and stuff that can get moved by the river during the flood conditions. The one thing that I always say is predictable is that the Red Deer River above the Dixon Dam is unpredictable. We know that it moves around a lot. It's a natural, it's a wild river. It's contained within its floodplain, but within that floodplain, as you saw, it's highly braided, and so where the river is one year, it moves quite a bit from year to year as a result of that flooding, and you get all these other little side channels and stuff. So it's something that needs to be considered for the future for activities in that area. Ongoing work, we've got inspection of the sites to ensure the end criteria met, and this was completed by September 17th, so that was to ensure that Plains had cleaned up to what we gave them as kind of a standard for meeting. There's continuation long-term monitoring program to assess the impact of the aquatic receiving environment. There still is the fisheries work that they're going to be doing. Reclamation of worksite areas has been completed at this point. There is still reparations to landowners and other affected parties on the watershed. And then one of the things that they are doing is, because they realize that the Red Deer River is a high-risk area, Plains is going ahead and doing directional drilling. So instead of that 0.81 meters, which is only about 3 feet or less than 3 feet below the riverbed, they're going to be drilling these to probably, they said in most cases, around 20 meters below the riverbed or deeper than that. So there won't be the risk of these pipelines getting uncovered and rupturing then in the future. And yeah, that's all I had, and I'll keep on track, but take a few questions.